Okay, next question on Skew boreholes. It says, on a contour map, A and B are 2 points with altitudes of 80 and 85 respectively. So A is going to be at 80 and Skew borehole B is going to be at 85 high. On the map, B is located 105 meters east of A. So that means scale is 1:1000, 105 meters, break it down. From A, I can go over 105 millimeters. Let's measure that. There's B. A and B found. Now, we can find the heights of them. And I think it said 80 and 85. So, 70. Add on 80, 15, and then the same with this guy, 85. So, just locating them, we have A up here, and we got B up here. So there's my 2 boreholes, points found in elevation and plan. Now, for borehole A, it says a Skew borehole at the given point A is drilled in a northeasterly direction in plan. So northeasterly, we look at our compass. So north, south, east, west, it's going up in this direction. So 45 degrees upwards in plan. So that's going to be the direction of my borehole. Somewhere up there, it's going to hit. Okay. Now, it also says in plan and has an inclination of 65 degrees to the horizontal plane. So like the last question that we did, we are going to essentially use that 65 degrees and we're going to think of it as the extreme generator of a cone. So what I got to do now is 65 degrees, going to get that on my protractor. I'm just going to pick a point out here. 65. Gone up here into my drawing a little bit. I'll use that as a guide. Okay. Now, after this, very simple. We're going to use sliding set squares to create that angle. From here to here. Angle created. And we will use 65. That angle there is the angle on or the angle it creates to the horizontal plane. Think of that, as I said, as the extreme generator of a cone. So if we look at the extreme generator of a cone, it's going to be coming straight out here. And with that, I will drop that down and I will rotate it around. Find the actual positioning of Skew borehole A. It's there. Now I can heavy that in plan. That's my Skew borehole A. Find that in my elevation. That is borehole A. And it also says for that question it reveals the top and bottom surfaces of a stratum of ore at 65 and 10. So very easy at this point. Just simply measure up 65 and 10. So just measure 10 here, 65 here. Make marks over. There's my 10. There is my 65. So, labels. There's AH, point on the head wall on borehole A, and AF, point on the foot wall. Okay, now we have to do the same with B. Now it says a skew borehole at B is drilled in a southwesterly direction. So come up here, southwesterly is going 45 degrees down this way. Somewhere down there. And it also says it has an inclination of 60 degrees to the horizontal plane. It reveals the top and bottom surface of the stratum at altitudes of 50 and 35. So, to be able to do that, 60 degrees to the horizontal plane, we can do it two ways. It's going to be going down in this direction, so I want to keep it neat and tidy and out of this section, so I'm just going to go at 60 degrees in this direction here. So, 60 degrees. Okay. That angle, 60 degrees to the horizontal plane. And as I said in the last part, like the extreme generator of a cone, that way that generator will be coming straight out when it's the extreme generator. We are going to bring it down and rotate it about. So nice and simple. Out here. And what I have now found is my skew borehole B. That is skew borehole B in plan. Same thing, I want to find that in elevation and then find the head wall point and the foot wall point. Made up. That's where it hits the ground in elevation. It still has a 60 degrees inclination to the horizontal plane, it's just we've found the exact positioning of it in a southwesterly direction. So, at this point again, it reveals the top and bottom surfaces of the stratum at altitudes of 50 and 35. So the exact same thing at this point, 50 and 35. So, there's my 35, there's my 50. So, labels once again. In this case, I'd have BH, BF. At this point, we know that we want to join our head wall points and our foot wall points in the elevation and the plan. So, I'll join them up in the elevation, then I'll locate them in the plan. Head wall and foot wall. They are not the exact head wall and foot walls, but what they are is points on it. And you're just connecting them up. So I'll do it for B first. So BH will be down here. BF. AF, same with AH. Once again, same thing, labeling very important. AH, AF, BH, BF. Locate those points in plan, or locate the lines. So there we go. Now what we actually have to do is we have to locate our strike line, because it says determine the dip, strike and thickness, and before we can get the dip and the thickness we need to get our strike. So I'm going to do in my elevation a level line across from the top point on my borehole A, my head wall point here, and what I'm then going to do is do a parallel line from the bottom point on my, from my borehole B point, and I'm going to go parallel from BH, which is a point on my head wall in borehole B, and I'm going to go parallel to the foot wall to create a plane up here. So, set up sliding set squares in line with your two foot wall points. and from BH going to locate a point out here that we will call point P. That point P, I'm going to now drop that down to my plan. It has to be down there somewhere. If it's in elevation, down here somewhere, and follow the exact same steps. From BH, which was this point here, we're going to go parallel to our footwall points. So, parallel to our footwall points, which was AF and BF, I'm going to do it from BH. I might need to extend down my line a little bit further. Yes, I will. So, I can see the direction of it. They are parallel. I'm going to extend this one down. And I will extend this line out. What I've located there in plan is the point P. Join that back to AH, which is over here, and that there will give me the true length of my strike. Up here, this line here, this purple line, I'll put it in purple now. That is also my strike. However, it is not the true length. It is the true length in plan, because in the elevation it is parallel with the XY line, and when two lines are parallel in one view, it means that they are going to be, one is parallel with one of the principal planes, which in this case is the vertical plane. It's parallel with the horizontal plane, which is the floor. So this strike line parallel with the horizontal plane, which is the floor, down in plan, that's going to give us a true length. And what we're going to do now is we're going to look out along that true length. And just to actually go back to that again, this was parallel with this, and this was parallel with this. Now, to complete the rest of that question, we're going to look out along our strike line that we got to find the dip and the thickness. So, extending out that, extend it out here. Do the same with my other points. So, do the same with BF, BH, and AF. There we go. And I'm now going to set up an X1, Y1, perpendicular to them. And if we project from the plan, we're going to take our heights from the elevation. So, very simple. I'm going to locate AH, and AH is down here, so it's out along this one. So there's AH. I'm going to locate BH, locate my two head wall points first, and BH is out along here. So label them AH, BH. Now I'm going to locate my footwall points. Start with BF. F is down here, it's on this one. And then AF. And once again, label. So I've now found, just make sure, this was BF. And this should be BH, or AF, sorry. There we go. Now, at this point, I would join the two head wall points, AH to BH and BF to AF. And as I said previously, always just check your accuracy first. So, let's see how accurate I was. It's coming out pretty close, yeah. They're pretty much bang on. What I'll do is I'll extend this one down and extend this down, and what you can get inside in this area here is the perpendicular distance between them, which is the thickness, and then the angle created in here. Just switch up the pen. Is our dip. That angle inside in there is our dip, and this here is our thickness. So, question complete.